Oh.
Which problem are we doing?
I made up the problem. So you're writing the reaction between magnesium and hydrochloric acid. I want you to complete the reaction, balance it, and also assign the oxidation states.
Just do that. Unless you're supposed to do something else. That's a cute pen.
Hmm?
The pen.
Oh, thanks. It's all pretty though.
Is it one of those things called like Zoom movies? Really expensive.
Oh, I had no idea. My friend got this for me for my
What's that?
birthday. Oh,
Yes,
I
it's
think I know
balanced
what
on
you're
the road
talking about.
oxidation
Is
states
it the,
too.
Like good squares. but,
So
like,
let's
smaller.
look over
Yeah.
here. What type of reaction is this?
Single
displacement.
Very good. So single displacement of a metal and hydrochloric acid, you would expect salt and hydrogen gas. So for the oxidation states, magnesium is 0 in a metallic form. Hydrochloric acid, chlorine is -1, hydrogen +1. Magnesium chloride, chlorine is -1, magnesium +2. And hydrogen gas, as a gas elemental hydrogen is 0. Any questions so far? Now let's look at the oxidation states for each element before and after the reaction and see if we can observe any changes in the oxidation states. Do you see any changes?
Yeah.
Yeah, what do you see? Which one is changing oxidation state?
Hydrogen.
Magnesium.
Very good. So one is magnesium is changing oxidation states. It's going from a 0 to +2. So it's a change in oxidation state. Hydrogen, is it changing oxidation state?
Yes.
Yeah.
Yes, it is changing. From a +1 is going to 0. How about chlorine? Is it changing oxidation state? No. So chlorine on both sides, it stays the same. So in this reaction, we see two elements here that are changing oxidation state. So magnesium from a 0 is going to +2. Now, question for you guys. If from 0, magnesium is going from 0 to +2, do you think it's gaining electron or losing electron?
Losing.
It's losing electrons, so very good. So magnesium is losing electron. Now hydrogen from a +1 is going to 0. Is it gaining electron or losing electron?
Gaining.
Very good. So hydrogen is gaining electron.
I spelled losing wrong.
So losing electron is called oxidation. Gaining of electron is called a reduction. So in this particular example, I'm showing you oxidation and reduction both are happening. So when you see oxidation, reduction both happening in a reaction, you call this a redox reaction.
When it's happening at the same time.
So let's think about it in terms of electrons, transfer of electrons. So magnesium is losing electrons. Where would the electrons go? So you have a flask, you do this reaction in it, and magnesium is losing electrons. Do we have electrons floating in the flask by themselves?
Probably.
No. Those electrons are being gained by hydrogen. So if in a reaction there is an oxidation, meaning that electrons are being lost, there has to be a reduction where electrons are being gained. You can't have only oxidation or only reduction. The electrons are transferring. And from the transfer of the electrons, this reaction is taking place. If those electrons were not transferring, then this reaction wouldn't even occur. You wouldn't see any products. So magnesium from a 0 is going to positive 2, that's oxidation. Hydrogen from a +1 is going to 0, that's reduction. Now let's see how we write this in terms of the transfer of electrons, and without writing it in words, we want to see how we can break this oxidation reduction that's taking place in this reaction. So magnesium metal loses electron and become magnesium 2 plus, and since it's losing electron is going to be on the reactant side because magnesium is losing the electron. So by losing the electrons, it forms magnesium 2 plus 2 electrons. Yes?
So the reduction is the oxidation agent and the...
I'm getting there. Give me a couple of minutes, please. So, what does this equation represent here?
Oxidation.
Oxidation of magnesium, right? So I call this oxidation half reaction. So this is called oxidation half reaction. And why is it a half reaction? Because remember, just oxidation is not enough. Oxidation is always accompanied by a reduction. For now, I'm just showing the oxidation part. Yes? No, you're reading from this side, so it's losing. Losing electrons is oxidation.
Right, but you wrote +2E.
It's losing. So magnesium is losing. Losing meaning it's giving off 2 electrons. If it's gaining, you're reading this way. But your reaction is going this way. This is the direction of the reaction. So it's losing 2 electrons and it's forming magnesium 2. That's what you want to look at. Now, these 2 electrons, what happens to these 2 electrons? Which component here is going to capture those electrons? Hydrogen. So hydrogen, and we'll start with hydrogen +1, is going to gain electrons. And what does it form? H2.
Yeah.
But that
But does this seem right to you? Is it balanced? No. So to balance this, you have 2 hydrogen in this side. I'm going to need to have 2 hydrogen on this side too. Is it balanced?
Yes.
How about the charge?
No.
It's not chargely balanced, right? You have 2 positive, 1 negative. This is not balanced. You're going to need to have 2 electrons too, because each hydrogen gains 1 electron. You have 2 of them, so they're going to gain 2 electrons. Now, this is called reduction half reaction. And again, it matches what we talked about. Oxidation is losing the electrons. Reduction is gaining the electrons. When you write a half reaction, you still have to make sure your reactions are balanced, meaning the number of atoms should match in the reactant and products, and the charges have to be balanced too. So when I ask you to write half reactions, this is what I mean. When I ask you to write half reactions, it means that you're gonna assign the oxidation state, see which element is oxidizing, which one is reducing, and then you break it into oxidation and reduction half reactions. Any questions so far? Yes.
So when hydrogen did the redox for it to go from +1 charge to the 0, it only gained 1 electron, right?
Just to go from +1 to 0, yes, for 1 hydrogen. However, your product is H2 gas.
Okay.
So 2 of those, and that's why I have this coefficient here, end up with H2.
Okay. So 2 positive ones.
Yes, so the connection I want you to do here, you know, we taught you how to balance by just counting the number of atoms. But in reality, those coefficients that we teach you to just write there come from oxidation, reduction, and balancing of electrons. So here, 2 electron, 2 electron, 2 cancel out. So the net transfer charge of the electrons is 0. So those balancing coefficients, in reality, that's where they come from for redox reaction, from oxidation and reduction half reactions. Now, in Chem 50 or maybe Chem 40, we show you the reactions, redox reactions, where you can just put the coefficient based on the number of atoms. However, next semester, when you move on to Chem 51, you won't be able to balance redox reactions by just counting the number of atoms. You would need to write the half reactions and figure out what the coefficients are. That's how it's gonna work out. But just to give you the heads up, that's where the coefficients come from. Now, a couple of other terms that I want you to learn here. So magnesium is going through an oxidation. So magnesium is oxidizing. So the other terms that you will be hearing. Is it clear why magnesium is oxidizing? Because it's losing electrons, right? So hydrogen is reducing, or being oxidized or being reduced. Now look over here. Magnesium is being oxidized and it's providing these electrons which are important and necessary for the reduction of hydrogen. So I'm gonna call magnesium as a reducing agent. So magnesium is oxidizing, but it's a reducing agent. Why and how? Because magnesium is providing the electrons that are required for the reduction of hydrogen. Now, hydrogen is reducing. It means that hydrogen is an oxidizing agent. What does that mean? Hydrogen needs to gain electrons from somewhere, meaning that it needs to pull electrons from somewhere. Where does it pull it from? From magnesium. What's the outcome? Oxidation of magnesium. So hydrogen is an oxidizing agent. So it's important that after identifying the type of reaction as redox, writing the half reaction, it's important to be able to figure out which one is oxidizing agent and which one is also reducing agent. Questions? Yes.
I remember this confused me when I started chemistry. How come the Mg, even though the magnesium, even though it's oxidizing, how come it's called the reducing agent?
Because what does it do? By oxidizing, it provides electrons for hydrogen. So it's an agent. It's that factor that makes the reduction happening. So you call that a reducing agent. Because if magnesium doesn't oxidize and provide or form those electrons, hydrogen cannot be reduced. So the agent that makes the reduction of hydrogen possible is magnesium because it's oxidizing. What it also means is that when I do this reaction, magnesium and hydrochloric acid, I would need magnesium to oxidize hydrogen to reduce in order to get this product. In other words, I can't have a machine, external source, to pump electrons into a reaction and then, I don't know, provide electrons for this half reaction. Or I don't have such a thing that, captures a machine or something that captures all the electrons that are formed from the oxidation of magnesium. These two need to happen hand in hand so this reaction can basically occur. Questions? All right. So let's go back to your worksheets. Can you stop that, please? Thank you.